Hello, everyone. Nice to meet you all. Thank you for having me here. As mentioned, my name is John Gilhuly. I am the head of developer relations at Arize AI. For anyone who's not familiar with Arize AI, we are a platform for evaluating and observing different AI agents or LLM applications that you might build. You guys have heard a lot today about agents and how you can build them and different techniques that you can use. Today, we're going to get into more about the evaluation strategies and some optimization techniques that we can use. And we're going to go decently technical here. This is the 300 technical track, so I'm going to make use of that as we go into this. Want to get a quick sense in the room, though. Who has built an agent before or is working on an agent? How many of those are in production? Okay, I love that because like every hand goes down, but good to see so many people are building agents. So a lot of the focus of this talk is how do you get your agents production ready, or how do you get them to the point where they can be in production? I always like to start with this because this is my collection of cases where agents or LLM systems have gone wrong in very public ways. These might look familiar. My personal favorite is the far right. It is somebody who convinces a Chevy chatbot to sell them a Tahoe for $1 and say it's a legally binding agreement. So you imagine there's all these cases where agents go really, really wrong. There's also lots of cases where they go wrong in more mundane ways. They just have bad responses. They don't address the user's question. It's not always this acute, crazy thing, but in this case, you have some of those as well. And so a lot of what we do at Arize is all focused around preventing these situations, understanding where these happen, and understanding the failure modes. This is a tech talk, however, so I'm not going to talk to you too much about Arize specifically or our product. I'm going to go much more into the strategies that we use to evaluate agents at a more kind of conceptual level. So I'm going to go through a few different pieces here. We're going to start talking about how you can evaluate agents, how you can break them down into different sections that you'll then evaluate through different techniques. And then we're going to look at how you can build a loop with these different techniques to have constant improvement over time. Lastly, we're going to go into an actual full, like, self-improving agent, fully contained automated system here, which is something we've been working on just recently, which is I'm very excited to share with you all as well. So first off, we break things down into the kind of components of agents that you can evaluate. I don't really want to get into the whole what is an agent, what is agentic, what's not an agent kind of thing. This is the typical kind of structure we'll see for how you would break down the pieces of an agent. You typically have some kind of routing logic that you'll use. That could be a defined single router that takes in a user input or the current state of an agent and decides what to do next. It could also be a case where you have routing logic spread throughout your whole agent. It's not always just one individual step. Sometimes it's spread throughout the agent. And then beyond the router, you'll also have skills that the agent can execute. And so those are what actually does things for the agent. There are API calls, there are other LLM calls, there are RAG pipelines, all kinds of different things that actually complete the task the agent needs to do. And then finally, you also have memory, which is kind of tracking the state of the agent as you go through. So I mentioned the router is the piece that takes in the user query, or it takes in the current state of the application and decides what to do next from there. Oftentimes, this is an LLM with function calling. It can also just be a classification task of some kind. You might even have really basic kind of code-based logic. That gets more into the discussion of what is an agent versus what's not, but we'll leave that to the side for now. Then you'll have skills, and so skills are going to be the different things that your agent can do. So again, these can be other LLM calls, they can be application code, API calls. If you take a common example we see a lot of times of a kind of a customer service chatbot or something like that, you might have skills to look up products or to make API calls to your customer success team and kind of pull in a customer success agent or something along those lines. You might have database lookups or full RAG pipelines as well. So we'll evaluate those pieces. And then you finally have memory. Memory we're not going to look at from an evaluation perspective too much today, but memory is going to be what allows you to track what's happened so far in your agent, what's the current state, what messages have been sent so far, or any kind of configuration information that you need. And so I would kind of argue that the three of these together really make up the main components of most agents that we see out in the wild right now. It's simplifying a bit, but from the perspective of what to evaluate, you can usually categorize things into these different sections. So the next piece here is how do you actually evaluate these things? What pieces do you evaluate within these? So obviously, we're going to be evaluating the router. We're going to be evaluating the skills and the functions themselves. And then finally, the path. The path is kind of the most interesting and the most new right now. So we'll talk a little bit about some of the techniques that are there. The router is, as we mentioned, kind of what decides what step to call or what path to go down in the agent. Usually there's two decisions that are being made or two things that could get wrong. There is the which skill do I pick, which path do I pick for a given input or for a given current state of the agent. So it has to get that decision right, and that's one thing that we can evaluate. The second is going to be, does it extract the right parameters? So does it pull the right things from the current message or state to then pass through into the next step that you go down? So if you think about the case of a travel agent where a user might ask, help me book flights from Toronto to San Francisco on the 23rd. Your agent has to decide, okay, the right skill to call is my flight lookup API skill, but then it also has to know that Toronto is my origination city, SFO is my destination airport, and then the date is the 23rd. And in practice, we see agents getting the right choice of skill more often than they get all the parameters right. So that is one of the other key things to kind of evaluate here as you're breaking down the different pieces of your agents. The next piece is your skills and your functions, so the different paths that your agent can go down. This is a little bit more custom depending on what that skill is. You might have traditional kind of code-based checks for API calls. So say you make an API call, do you get a 200 response or do you get a 400 response or something along those lines? You might also have LLM-powered evaluations for full RAG skills. You might evaluate things like the relevance of retrieved documents from a vector database. You might evaluate the code generation quality if you have a code generation step. So all kinds of different things that you could evaluate depending on the skill itself. And so this is going to be the one that has the most kind of variance to it as you go through. And then finally, the third piece here is the kind of the path of the agent, or we talk about this as convergence sometimes. But this is really, does your agent take the most efficient path to answer the user's question or answer the original input or task? You might have cases where an agent gets to the right answer, but it does it by looping through the same step multiple times and doesn't need to do that. So you can't just look at the overall outputs of your agent and expect to understand whether it's performing well. You do kind of need to look at the actual path. I mentioned this is the one that has the most variance of how you actually evaluate it and how you go about doing it. In practice, we see a lot of people who are comparing the path of an agent to some sort of ground truth data. So they know the exact steps that an agent should take for, say, that same flight query from before. And then they compare the actual path to that ground truth data. That's one way you can do this. Obviously, that doesn't scale into production. That's something you can do in kind of a development flow. So we see people going for that kind of technique. And then we also see cases where people will just count the number of steps that are completed by the agent. They basically track the number of times it goes through certain functions or certain skills. So we see a few different techniques for doing this right now, but generally some way of evaluating the path is going to find its way into your eval suite. Now, you might have noticed that I've basically taken this flow of breaking down the agent into multiple different pieces that we evaluate. This is kind of how we are putting forward the optimal technique for evaluating agents. There's a whole nother school of thought of just evaluating kind of the overall outputs, the overall inputs and outputs of that agent. So for a given input, does it actually get to the right answer for the user? That's another way of approaching this. I think I would argue that you kind of do need to break things down into individual pieces to actually understand where things are going wrong. And so this technique of breaking into each individual piece is the way that we typically do that. You have your evals, you have your different techniques for how you would actually run these different evaluations. How do you turn these into some sort of system where you can show performance improvements of your agent over time? So this is the kind of the cycle that we have a lot of our customers at Arize doing, a lot of our users are doing. And this is what we put forward as the way to show that improvement over time. It's a cycle, so you can start kind of anywhere on this loop, but I typically would start with the bottom right, where you're looking at the data set creation of failure cases. So typically we'll see people starting off with some sort of ground truth human labeled data. So if we go with our travel agent example, you might have cases where you have a bunch of different inputs that you would expect, or maybe 50 or so different types of questions you expect your users to ask that agent. And then you would know the expected tool calls for those. You would hand label the expected outputs. You'd kind of go through the whole exercise of labeling those different pieces so you have ground truth to compare against. And then you can use those to kind of fine tune your agent. So you can use those to benchmark how your agent's performing. You can try different prompts, you can try different logic, different tools, all kinds of different things to try to boost your performance on that ground truth human labeled data set. So it always comes back to human labeled data in some way. So you can use that to kind of create the most high performing agent based on those test cases that you've defined. Then from there, eventually you're going to deploy your agent to production. And once you're into production, you can start capturing telemetry data on how the agent is performing. So you can see, okay, are there questions that I wasn't expecting that users are asking that is not included in my original test set? Are there failure modes that I wasn't anticipating? Is my agent really bad at handling different languages? Or maybe it's really bad when people put 2 cities that they need to fly to into it, for example. So you start to learn from production on where your agent is making mistakes. And the really key thing here is that you can use the same evaluation techniques that you use in development in production. So if you're using either LLMs as judges, if you're using kind of LLMs to evaluate different parts of your agent, or kind of code-based checks, you can run those in development, get a benchmark sense of how your agent's performing there, and then run the same ones in production. And then that will allow you to know, okay, these are the types of changes that I need to make. These are the types of cases where my agent's not performing very well. And so you fold those back into your data set of test cases and kind of continue the loop from there. In terms of LLM as a judge, show of hands, who's familiar with that term? Okay, most people. For anyone who's not, as the name implies, LLM as a judge is using a separate LLM to make judgments about some part of your application based on the inputs or the outputs of that application. And so oftentimes around this point, I'll get questions from people saying, oh, LLM as a judge is not accurate. You're just using another LLM. Isn't that going to make the same mistakes? Aren't you going to have the same issues there? The answer is yes, it will not be 100% accurate. However, you can use this same loop as well to optimize the LLM as a judge. And this is kind of the advanced mode that we see people going through as they start to set up more robust testing suites. But you can do the same loop here of actually building a data set of ground truth cases here and then adding human labels to those, fine-tuning your LLM as a judge, either just tweaking your prompt or even fine-tuning a whole model. There are some people who actually go through that length. And then deploying that to judge your application. So with all of these together, you can have more of a sense of how accurate your LLM judges are as you try to feed them into this improvement cycle that you built. Oh, I see people taking pictures. I'll give it 1 sec. I think we share the slides afterwards as well too. And if we don't, then just come find me and I can send them to you. So now this is kind of the state of things today. This is what we help people do at Arize, is kind of build up this whole sort of cycle. Our product is all around kind of tools that help you do this, either open source or kind of through a SaaS product. So this is all within the realm of kind of like what we do today at Arize. This is the point of the talk where I now get to talk about the fun stuff, which is the new things that we're trying to do from here and kind of the R&D, and that's part of what falls under my role, and I get really excited about this stuff. So the big question here for me is, okay, we've built this. Can we just automate the whole thing? Like, is there a way that we could actually just make the agent improve itself? Or is there a way we could turn some other agent on this agent to then improve it? So we've been experimenting with ways of actually automating this full loop and seeing if we can improve that and just sort of create this automatic improvement cycle over time. So how would we automate it if we were going to automate it? Well, if you look at this actual cycle, this is the same one from before. Nothing's changed so far. There are only really a few steps that are like human intervention steps. So you have your human labels, obviously at the bottom of the circle, and then you have the fine-tuning step, which is usually where you're making changes to your agent to try to improve its performance in different areas. And so usually that's done by people going in and changing prompts or changing like tool descriptions or logic or things from there. So those are really the 2 things that we would need to automate if we're going to actually automate the full loop. So you can see we can remove that human labeling step. That's step 1. In this case, instead of adding those human labels, we're relying on our LLM judges, or kind of our evaluation labels there. So we can still do the same loop of tracing in production, running LLM judge evals on that, getting labels from that, and then feeding those in failure cases. But in this case, we're actually relying on the LLM judges to be correct, as opposed to having a human come in there and say, yes, that was a failure case. Yes, this one is something that we should improve on. The other piece is that we have to automate the fine-tuning aspect, the actual optimization step from there. And that's the piece I'm going to focus on today. Happy to take questions afterwards around like the accuracy of LLMs and judge labels. That's a whole other area that we could get into. Short answer there is you can get LLM judge labels to be 95% aligned or so with human judgment on most tasks. Just is a matter of using large enough models in this case, and in some cases using multiple models and have them do kind of a majority vote for the evaluation label. Happy to dive way more into that if anyone's curious. But I'm going to focus the rest of our talk today around some of those automatic improvement techniques that we can add in. And so there's a few techniques for those optimization improvements. Folks are probably familiar with at least one, maybe more on this slide as well too. But a lot of this focuses around kind of prompt optimization. And I'm saying prompt optimization, but really this can also apply to function descriptions. So if you're passing tools into a prompt or something like that, this can also be applicable there as well too. And so there's a few different options. Few-shot prompting, I'm guessing almost everyone in the room is familiar with few-shot prompting. The idea here is you just add in examples of ground truth data into your prompts to kind of align your LLM. That's the most basic version of this, but is something that is going to be helpful in cases. The next piece is meta prompting. It looks very complicated, but it's very simple. Basically, it's the same kind of idea as LLM as a judge. You are taking your full prompt as well as some example test cases from it, of cases where it was correct and incorrect, shipping that off to another LLM and saying, other LLM, critique my prompt. How could you improve it? How could you change things from there? So this is a very easy technique to go do, but one that we've actually found to be very, very effective, and I'll get more into that in a little bit here. The next technique is gradient prompt optimization. Interest of time, I won't get all into the details here, but this is a very cool technique to check out if you're curious. Basically, it involves taking your prompt, converting that into embeddings, and then taking sort of ground truth examples, converting those into embeddings, and then using kind of computing cross-entropy loss as you run those examples through your prompt, and then taking the kind of gradient loss from there and applying it to the embeddings of your prompt, and then converting that back into text. If none of that made sense, don't worry too much. This is like a fun thing to dive into later, but it's using embeddings as opposed to just using pure text to do more of a mathematical improvement of your prompt. This is cool and works in some specific cases where prompts are very, they need very minute details and minute changes. In practice, we actually see meta prompting beating gradient prompt optimization in most cases. So very cool, but something to just check out if you're interested, not the main technique we see people using. And then the final piece here is just prompt optimization libraries. If anyone's used DSPy or Zenbase or some of these tools, there's a whole set of libraries that you can use that just take the common prompt optimization techniques and make it really easy to run those on your application. And so these have dozens of different techniques in them. There's a whole area of academia here around prompt optimization techniques as well too that you can dive down if you want. So we wanted to basically take these techniques and figure out, okay, do these actually work? Are they effective? And so we started out by just doing a basic kind of multivariate classification task here, where we trained with about 100 different records, and then we tested some of these different optimization techniques. What we found was that meta prompting on its own actually worked the best here out of the different optimization techniques. It provides a slight boost in this case that you can see. This is pretty minimal. I don't know that I would really go to a ton of effort to get that extra percentage point or two. You guys may feel differently, but it has a small benefit that comes from this particular task. The key insight here, though, is that the existing baseline prompt is still correct most of the time. So this is kind of where we started. Then figured out we needed a harder task. We needed something that was harder for models to do just out of the box to see if the prompt optimization techniques would actually have a big shift. So the next thing that we went to was basically building out our own technique for prompt optimization. We call it TextPro. It's essentially just meta prompting, but we just add some extra variables into that, which I'll get into in 1 second. But to kind of break it down, we tried a more difficult example here where we said, okay, we're gonna have a prompt that has to take in a user input and turn that into a website. So we have to generate a bunch of JSON information around what the different elements on that site will be, kind of what the code will be for that, and kind of create that kind of output. And so we ran that through a bunch of different models, and we had kind of a hidden set of rules to say, okay, we need to have things like the meta description tag needs to always be present on any website we generate. And so we had that. We had about 50 of those rules that we had kind of hidden behind the scenes that were encapsulated in what needed to be kind of addressed by the prompt. And so this diagram is kind of just showing the loop that we used here, where we would have the initial prompt and then send that through our application, see the output, and then we would take that prompt, send it off to an optimizer LLM with a bunch of what you see in green, which is basically feedback data. So what we did is we used this, what we're calling TextPro, which is this meta prompting technique essentially, to incorporate 3 different pieces of info. So it incorporated actually really 4 different pieces of info. I should update this, but it incorporates a label on whether or not the agent had the correct or incorrect output. And then it incorporates an explanation of why that was the correct or incorrect output. So it's very hard to see, I bet, in that example, but the green, for example, there's one case where it's the application is asked to generate a web page, and then it fails for the reason I mentioned, basically a meta tag not being included in the headline. The explanation would say as much. It would say there was no meta tag included in the headline. The annotation is more an explicit description of exactly what is missing. So in this case, it's pretty similar, but in some cases, it's more of a sort of refinement of what was missing in that case. And then the rules is basically a sort of more broad catch-all definition of what rule needs to be introduced or updated to make sure that this doesn't make that same mistake again. So in this sort of example, we end up generating a whole list of rules that can be followed by our different prompt here. And so what we found as we tested these different techniques is that obviously if you send a bunch of these queries through a base prompt that doesn't know anything about the rules that were defined there, then you're going to get almost 0 correct because it doesn't know those specific requirements. If you just pass in the rule set itself, then you are going to get some more accurate examples. That's the blue diagram there. So that's just passing in the rule set as written. What was interesting is that TextPro actually beat out the rule set as written. So even giving the LLM the answer key was not as good as this TextPro technique that we put into place to optimize. The last bar that you see there is TextPro Plus, which is just the same process that I mentioned, but run about 500 times, giving you 500 different prompt candidates that we then test against each other to get to one winner. That requires a lot more LLM calls, and so it's a much more expensive way to do it, but it does give you boosted performance in almost all the cases up here. So this is kind of the technique that we're now taking forward and pulling into our product. So we're going to have some way that you can actually run optimization flows here directly out of your dashboard in this flow. We're going to use this meta prompting technique. I think the things to call out is that while it does give you that boost, it doesn't bring things all the way up to 100. You're still maxing out here at 71% accurate here, or I guess 85 in that case of the TextPro Plus. So you're not getting to 100% still here. While you are showing some boost, these optimization techniques don't take you all the way, unfortunately. And so if we look back at the kind of fully improving agent over time, then while we can do this and we can turn this cycle on, I wish I could sit here and tell you that we've solved how to make your agents work really well with some automated flow. And we can turn on that automated flow, but it's not going to get all of those cases exactly correct. And it's only going to show some of a boost. So if we turn back to that original question of can we automate this loop? Yes, we can, but we probably shouldn't yet because it's not going to actually take you all the way. So it is something that you can use as another input into your flow. You can do kind of supervised improvement using this kind of automated loop, but it still does require a human to be in there actually improving the prompts or the behavior or the code of your agent as you're going through. And I think, and the last piece I'll show you here, this is the one screenshot of the platform I have for you. I'm trying to keep it mostly conceptual, but it still is important to have your heads-up display of your different evals on different parts of your agent to understand where things are performing so that humans can go in there and actually make the updates that they need to make, even with that optimized automated loop below you. And that is about all I have for you guys today. I think we have a couple minutes for questions. I know I went a little long. Last thing I'll say here is that I put the full flow of the full notebook that just goes through that whole flow using our OSS tool in that middle QR code. So it doesn't necessarily have kind of all of the all the TextPro kind of optimization, just uses basic meta prompting. But if you want to run that full flow, you can do it at that notebook. Thank you very much.
Please raise your hand so our mic runner, yes, in the front.
Hi, I'm BLEU from National Bank. Can you go back to your slide when you present your TextPro process? Yeah, this one. If you look at the green cards in the middle, are they generated automatically, or is there some annotation by a human expert in there?
So in this case, they're generated automatically through an LLM. Part of what we wanted to prove is can we use LLM generated labels as the input into the optimization process. So for this example, we did generate them with LLMs. We did then go back and kind of review them to kind of understand whether they were accurate or not. We have a version, all the data I've shown you is without changing any of that after the fact. We did try and make some tweaks from our end as well too. But generally speaking, they were kind of good out of the box with the LLMs that we used to generate them.
Okay, and a follow-up question. Do you think that it would improve the process if there were human experts reviewing it?
Human experts, yes. If we were able to have human experts review, and in practice, when people do this kind of full loop, that's where they have the humans coming in. They're not actually just going and labeling all the examples themselves. They're having LLMs label them and then have the humans come in and actually do kind of review of that. I will say that it does need to sort of be people who are intimately familiar with the use case or the subject matter, depending on what the case is. I think what we have found is if you just use kind of labeling services that are maybe just generic human labeling services, they tend to be either not as good as the LLMs or at best, just as good as the LLM labels.
Again, thanks for the nice talk. The list of rules that you have put in the rule set, These are, of course, human-generated, and you input them into the annotator LLM?
So in this case, the rules that go into the optimization process, that actual rule string, is LLM generated. We have kind of predefined a set of criteria that we can kind of compare to those rules. But the idea here is that those criteria are kind of fixed beforehand, but we wanted to see if they can be almost identified and inferred by the LLM as it goes through and determines whether these are kind of correct or incorrect cases.
And when you say criteria, it would be things like the ISO 8601 timestamp, and which are obviously input by the human as set of criteria that can then be leveraged by the LLM as templates.
Exactly.
Okay, thank you.
Hi, thank you for the talk. I was wondering if in Arize we can do parallelization for these workflow optimization, especially when we talk about using LLM as a judge. One of the biggest problems is, for instance, if I need to evaluate 2,000 samples, it can take me a lot of time done sequentially. So yeah, is there any parallelization in Arize for that?
Yeah, so we have a whole, either you can run those evals through our dashboard or through a Python package that we have. In both cases, there's an element of concurrency that you can do. So you can define a kind of a concurrency parameter of how many of these you want to run in parallel. So you can kind of run those in parallel sideways. I will say that so far I'm kind of talking about these as after the fact evaluations. So it's not blocking the main thread of the application, like it's not evaluating before sending a response back to a user. We do support those as well, kind of call those guardrails typically. And so with those, there's more of an element around how do you actually optimize that speed. But to answer your question, yes, there is an ability to run concurrent evals either through our dashboard or through our Python package.